Welcome to Switching to SQL File Definitions from Legacy DDS. I'm Bob Cozy, and this is part of my SQL iQuery training series. If you'd like to download a copy of this presentation in PDF form, we have a copy for you waiting at SQLiQuery.com. SQL iQuery is a web or green screen command line SQL processor. It has a powerful scripting tool called Silk that supports IBM DB2 SQL, and you can run any SQL statement you want. But in addition to that, it allows you to transform your database using SQL into one of several formats. You can output CSV, JSON, Excel, PDF, XML, and more using SQL iQuery. It's both a command line tool and a source processor, so it'll run SQL scripts or allow you just to run that ad hoc statement from within CL, including the select statement. All right, let's look at classic DDS and show how to move to SQL directly from legacy files, such as the one we're showing here. It's a sample customer master file. You've seen it all before, nothing new to see here. We've got a record format name, it's called custrec. We've got some column definitions right in the middle of the fixed format DDS specs. Keyword orientation for additional field properties. Here I've got column headings. I know some people like to use the text keyword. I was never a fan of the text keyword because column headings are converted into text, but text are not converted into valid column headings, so I prefer to use column heading. And then down at the bottom, we can put key fields and select and omit criteria if we choose to do that. Although on physical files, you would never use select and omit. On logical files, you would. So here we have one key field. It's a primary key, customer number. We've all seen this kind of file before. To create files using the DDS method, you use the create physical file command, as you've known for the last 40 years. The change physical file command can also be used when we make changes to the database. For example, if we have to increase the length of a field, we have to add another field to the end of the file or in the middle of the file. The change physical file command allows you to do those things without violating the data integrity. So it preserves the data that's already in the file for you. This has been around for decades, going back to probably version 3 on the operating system. But a lot of people don't even know it's there even to this day. They tend to copy a file, change the definition, then copy it back with copy file format option map drop. The change physical file command does all that for you and does it better. And when you prompt it, it looks pretty much like the create physical file command, only all the existing attributes are already filled in for you. You can change anything you want, although people typically don't change anything here. They just change the DDS, maybe the column headings, maybe another field, maybe a key field. And then they press enter and the file gets transformed automatically. Now what about SQL for I data definition language? To define a file, which is called a table in SQL, it's substantially different syntax, but most of the same components are there. So here we have a file that's being created. It's called cusmast. Effectively, everything from the original DDS is right here, with the exception of the column headings, which I'll show you in a little while. The key difference here, obviously, is that SQL DDL is free format syntax. It uses keywords and parameters and various options, and there's multiple statements required to create a file and add column headings and text descriptions, versus DDS, which just has one set of statements that does everything for you. But for the most part, as you read and get familiar with SQL DDL, you'll actually prefer it over DDS because it's more natural and it's more flexible than DDS could ever be. Okay, but before we look at the specific differences in each statement, let's look at DDS. DDS is keyword oriented. You have one line or one statement per field definition. You can put multiple keywords on multiple physical lines, but there's still one statement that they relate to. SQL DDL is statement, keyword, clause, and value oriented, so there's a lot more parts to it. So in addition to column definitions, you also can add column attributes later on in other statements. And you can actually change specific columns individually instead of having to change the entire file definition and recreate it. You can actually go in and just alter a single column or a single field in an existing file. SQL allows you to do that. For example, something I do all the time when I come across a legacy file that doesn't have column headings, you can use the alter column statement in SQL to add column headings to a field or multiple fields in a database table. And it doesn't impact anything. It doesn't cause a level check. It just works. It's a wonderful little tool. IBM has frozen DDS, so you're not going to be getting any more updates to it. You can hold your breath, you can be disappointed, but that's the way it is. Let's move on. SQL Data Definition Language is the new database definition standard. I hate to say the word new because it's been around for a long time, for decades. However, IBM has now dropped DDS. They're not going to enhance it anymore. So when you want that temporal support in DDS, or you want that identity column in DDS, you're never going to get it. You have to move to SQL DDL for your file definitions and for everything else in that matter. Display file DDS, however, is still being maintained, but it is largely unrelated to database DDS except for the syntax similarities. So that's a story for another time and not part of this presentation. Transforming DDS to SQL DDL is a little bit of a journey, but it's a very short journey. Since SQL uses data definition language to define things, you have more lines of code that are needed to accomplish the same things as were done in DDS. But it's worth it. You do a create table and then you do a label on, you might do a grant, a lot of different things that go on, but it's worth it, and it actually is a much more robust environment to work with. Now, to get to the DDL, which is really the point today, you can manually write the new data definition language. Sit there and look at your DDS and translate it through your keyboard and your fingers. You can use an API called QSQ Gen DDL, and it's actually what's behind the SQL iQuery Retrieve SQL Source command that's provided with our product. So if you already have our product, you already have this command. Or you can use the relatively new IBM Generate SQL Stored Procedure, which is actually pretty good. Now, the API is a good choice if you want to write your own little setup and do your own little conversion, or use the Retrieve SQL Source command that comes with SQL iQuery. The Generate SQL procedure, however, is pervasive. It's on everybody's system. While it does have a complex parameter list, it's easier to learn than the API, and it's not that complex. It's just a little different. Here's the Retrieve SQL Source command that comes with SQL iQuery. You can see that it has all basic parameters on there. Usually I let everything default, with the exception of the generate, create, or replace statement. We really want to generate a create or replace statement instead of just a create, so that we have the option of redefining the file and preserving the data, and not just failing when the create runs because the file already exists. That's about the only option I change on here. Now, the Retrieve SQL Source uses the API under the covers, as I mentioned, to extract the file's definition. With the current technology refreshes, as long as you're on version 7, doesn't matter what release, a good alternative is to use the IBM supplied SQL Stored Procedure, which comes in the QSys2 library. This procedure is not something you do from the command entry screen or from CL. It's an SQL stored procedure that's called. So it must be run from a valid SQL processor. Here's the syntax for the Generate SQL statement. The first parameter is the file name, then the library. You've got the object type, source file library member, and then additional options. And I'll go over these for you and show you a working example. Remember, this stored procedure must be run from a valid SQL processing environment. So that means it has to be run when it's embedded in RPG, or from the RUNSQL command, although that's a little kludgy, from the RUNSQL statement, which allows you to run it out of a source file member, which is how I prefer to do it, or run iQuery, which also allows you to run it out of a source member or from the command line. You could start SQL and just do it one-off if you'd like. And you can use the RunSQL scripts, which is part of ACS. And I believe there's also something in RDI as well that does similar. So you have lots of choices to run SQL statements nowadays. My preference is to either use the RunSQL script statement as part of ACS, Or if you're going to actually have a real scripting language like Silk and run iQuery, I would use the run iQuery command to do that. Those would be my two choices. Here's a fully functional version. If you cut and pasted this in right into Start SQL or the ACS RUNSQL scripts program, it would run on your host server, and you would generate a source file member named cusmast that contains the source code for the data definition language for the customer master file that exists in Cozy Test. Now, one caveat, the source file member, which is cusmast in QSQL source and Cozy Test, must exist. Currently, there's no option to add the member automatically for some reason. First interface I've seen in decades that doesn't have, add member, but it doesn't. So remember to add the member first. So the first parameter is the file name, then the library, then the file attribute, which is table. All physical files are tables in SQL. Then the source file library and member name. Now the last parameter on this example is the statement format option. It is essentially a required parameter because without it, the source file will contain an end-of-line character and a tab character after the last non-blank position. And when you load it into SEU, you're going to have a lot of reverse image and underscore show up. I suppose if you load it into RDI, it may look okay. I don't know why it defaults to 1, it just does. I've asked IBM about it, but at this point they haven't responded. Here's what it says on the IBM's website for the formatting option. The formatting option is used in the generate SQL statements. A 0 means no additional formatting characters are added to the end of the generated SQL statements, which is what we want. A 1, which is the default, if it's not specified, adds additional end-of-line and tab characters after the end of the SQL statement. So you get a bunch of junk at the end of your SQL statements. So I'm not sure why you would want that in a source file member, but that's what you get. All right, let's go ahead and run this. We're going to do the custom master file shown earlier. It already exists. So we want to migrate the DDS to DDL, and we want to produce a create or replace table statement, followed by a label on table statement, followed by a label on column is for column headings, followed by a label on column, spelled incorrectly there, text is for the column text description, and then it's going to generate a create index for the key field. Now, we probably don't want it to do that, so we may go in and edit the source code and change it to use a primary key, and I'll show you that. Now, all we have to do is generate the DDL by calling the generate SQL stored procedure. So here's the statement we're actually going to use. I've added an additional parameter here, replace. This says replace the source member if it already exists. Since I was running this multiple times, I decided to add the replace option because it kept adding it to the bottom of the source code. And then I also want to tell it to generate the create or replace table command. So I add create or replace option equals 1. Actually, it's equals with a little greater than symbol after it, so it looks like a mini arrow. And then the 1 in quotes. And I'll go ahead and run this, and we end up with pretty good looking SQL DDL. We have the create or replace table, we have the file name, we have the record format name, and we have all the column attributes from the original file. In fact, we've got the date and timestamp stuff out there now, so we can actually put in things like current timestamp, current date. We have a user field out there, second to the last field. We could even put default as the current user if we wanted to in there. Now note on IBM I, a current user column has to be 18 characters wide for some reason. Otherwise, it ignores the default. So let's compare the two things. We have the original DDS in the top right, the green screen, and we've got the new cool data definition language down there on the right. There's the record format way down at the bottom. That's about the only thing that's upside down is the record format name, which is an IBM I extension, kind of proprietary thing. It goes down at the bottom there. Column definitions are all in the middle, similar in structure. But wait a minute, where's the key field? I don't see it here. Well, what happens is down below the create or replace table command, there is a create index command that generates a second object, an index, with a generated name over the customer number field. And this is fine if you're going to use SQL. So what we're going to do is a manual step. We're going to take the key field and type in primary key so that when the file is created, the primary key is also created. Now, as far as SQL is concerned, this is exactly the same as putting the index with the constraint in there. There's effectively no difference. However, this does allow you to then put a key field in a file spec in an RPG program and use the chain opcode to chain to it by customer number. If you have multiple key fields, just separate them with commas within those parentheses, and it'll work the way you want it to. The rest of the generated data definition language is all about the text and the column headings that are inside of the original file. So we have all that here. We have the file's text description. So we say label on table. It puts the file name in there, sample customer master file. And then the column headings are there as well. Notice they're spaced 20 characters apart. So when they show up in a query report, like one of those created with SQL iQuery or even Query 400, it will stack the column headings the way you expect them to be stacked. And then last we have the text description, which is automatically generated in DDS when we compiled the column headings. It just basically concatenates each column heading with a blank between it. I guess that's a BCat, and then creates text description. So it's always better to use column headings in DDS, and you can see why here. Had we done it the other way, we wouldn't have gotten the nice column headings that are going to show up on all of our reports. Let's go ahead and run this source file member that has, about a half a dozen statements in it and see how it works. First, I'll run it with SQL iQuery, and then we'll run it with one of the IBM provided commands. Go ahead and run it, run iQuery, specify the source file member name and the source file and library name. Now, if you have QSQL source on your library list and the member is in that particular file, you don't have to put source file. You can just run the source member. So here it ran. The table's created. Actually, it's recreated, similar to change physical file. The file's not journaled, so we get this SQL state of 01567, but we can ignore that. That's just an internal message. iQuery will log any SQL state that's not 0 to the job log, so you can see what happened. But you can ignore anything under 2000 typically. Note that SQL iQuery has a default commit parameter of none. So if you want to use commitment control and journaling, you can specify commit and specify whatever option you want on there. But what we're finding is most of our customers with the files they're working on that are changing on a periodic basis, they're not having commits, and when they're running queries, they don't want to run commit. So we have it default to none, but you can certainly specify that as anything you want. All the commit options are supported. Now we're going to run it again, only this time we're going to use run SQL statement. Parameter syntax is largely the same. I've added the commit none since we're not using journaling here, and we get the exact same result, except run SQL statement doesn't log the SQL state, which is certainly not a big deal in this case. And we get the same results. So either one of those two tools can be used to process this. And that's really all there is to it to move to DDL. One last thing. In my shop, we use both SQL iQuery and its Silk scripting language, as well as SQL. And we use the run SQL statement to create our UDTFs, our functions, and our stored procedures that are all written in SQL. It does a fine job. It gives you the compiler listing. It shows you what it does. Everything works fine. We use SQL iQuery to run ad hoc SQL statements, such as select, update, merge, delete, insert, etc. In addition, the Silk scripting language has session variables, conditional logic, looping, and built-in functions and opcodes, as well as symbolic names. So it's effectively an entire programming language that's interpreted and goes above and beyond SQL. It doesn't interfere with any of your SQL statements. It basically allows you to program in SQL, including CGI web programming and use SQL as your database I/O. And there's a lot of other capabilities in it as well. It's very much based on RPG, so it's easy to learn. Free format RPG, of course. And it just works. And I've been using it for a couple of years now. And except for a couple of interactive subfile RPG programs, I haven't had a need to write RPG extensively for a long time. You should check it out. For more information, visit us at sqliquery.com. If you have any questions, go ahead and email me or send me a reply on Twitter. I'm Bob Cozy.